Hello world! Welcome at the Global AI Community on virtual tour. We're already quite far in our 30 hours marathon of sessions, but together with myself, I'm Sami, and together with the other host, Amy, we are welcoming another speaker for the coming hour. Welcome, Veronika.
Hi, everyone.
How are you doing?
I'm great, and you?
We're good. We're good. Thank you. So, Veronika, you are passionate about backend web development, and you're mainly focused on technologies like C Sharp, .NET, Azure. You're a public speaker, you're a hackathon volunteer, and you're also a Microsoft AI MVP. Well, Veronika, where are you located from?
So, currently I live in Boston, Massachusetts. It's in the US.
Okay. So, what are you going to talk about today?
So, today I will be talking about speech services and how you can make your applications interactive using those services.
Awesome. So looking forward to your session. So we give the platform to you.
Awesome. Thank you. So, as I said, today we're going to cover speech services. And here you can see my name. My name is Veronika Kolesnikova. And here is my Twitter handle. So if you have any questions later or you just want to chat, follow me there and ask questions. My DMs are open and I am trying to be active on this platform. So that is my profile picture. I didn't want to skip this slide because usually people say that I look different than my profile picture on Twitter, but that's me. If you see that, that's me. And as Samuel already told us, I am a software engineer and I'm working here in Boston. I'm focusing on Microsoft technologies. And my hobbies are dancing, traveling, and aerial yoga. So here is the agenda for next probably 40 to 45 minutes. I'll start with basics of Microsoft Cognitive Services, and then we'll move to Microsoft Speech Services. And speech services, they're a subset of cognitive services. Then we'll talk a little bit more about custom speech services and speech services SDK. We'll cover just basic things about those. And then I quickly provide an overview of similar offerings from Google and Amazon. And then we'll move to demo. And I have so many things in my demo. So hopefully we'll have enough time for everything. So let's start. So what are Microsoft Cognitive Services? If you joined earlier, joined the global AI event earlier, there were so many different sessions covering different cognitive services. But if for some reason you missed those sessions, no worries. You can watch them later. Second, I will introduce you to the cognitive services. Microsoft Cognitive Services, they are basically sets of APIs and SDKs that can help us developers to integrate machine learning models and tools into all kinds of applications. So even if you don't have a PhD in data science, if you know almost nothing about machine learning, but you're really interested in that, you want to implement maybe face recognition, images recognition, speech, and other cognitive services, they are all available through Azure. So if you have Azure subscription, you can find them there. If you don't, if I'm not mistaken, there is a 7 days free trial. So you can check them out and see if those are working for you. But they're really easy to implement. You can just write a couple of lines of code and access those services through a REST API. You get in the key and the endpoint from Azure, or from your trial. Usually when you create a cognitive service, that's when you're getting the key and the endpoint. They're all flexible, so it doesn't matter what kind of applications you're building. If you're a hardcore Android developer or you building iOS applications, maybe you can't live without Python. It doesn't matter. You can still use cognitive services and implement all the benefits of them into your applications. So they're all well tested. They have amazing documentation online. They're all open source, so you can see how they work, how they were built, and if you see that something is maybe not working right or something is confusing, definitely provide feedback, write an issue on GitHub, or if you know how to fix it, that's awesome. Just submit your pull request, and I'm sure that Microsoft will be happy to have your code there and your fix there. Those cognitive services, they were actually built by researchers from Microsoft. So those people, they know a lot about machine learning. They know data science. That's their specialty. So they built all those models for us, people who maybe don't have that much exposure to machine learning. That's why it's a great opportunity to start with machine learning and start with cognitive services, and then, if you like it, then build your custom models. So what is speech service? Speech services, as you probably guessed, they are covering all speech interactions. So we can understand our speech, and understand it's a really broad term. So I will explain in more details a little later. But speech services, they are powered by speech technologies used in products like Cortana and Microsoft Office. So they're well tested, and they've been tested for so long. They launched Cortana so many years ago, and then Microsoft Office speech support, we all know that it's pretty good. They're improving. They are collecting the data and then using that data to improve the models that they used for speech services. Before speech services were combined into one resource on Azure, they were separate, and it was separately Bing Speech API. It was part of the Bing suite. And then translated speech, custom speech, and custom voice. Now you can have speech to text, text to speech, translation, and then customization, custom speech as part of your speech service. So you're creating just one resource with one key and one endpoint. It is so useful. If you if you use several cognitive services, you probably know that it's sometimes really confusing when you have several endpoints, and then you need to manage the endpoints and the keys and make sure that everything is accurate, is updated, working correctly. And then, if something is missing, if a key is wrong, or I don't know, just missing in the code, then it's so challenging to manage several keys at the same time. So it's really great that they combine them together into one resource. So again, you need just one key and one endpoint for pretty much everything related to speech. I know that speaker recognition, it is also kind of part of that speech group in cognitive services suite. But for now, it's a little separate because it's still on preview. So be careful with that. But other than that, just go crazy and use speech services anywhere you want. So let's move forward. Speech services features. Let's talk about features. And as I mentioned before, we have several features combined together into the speech services. First is speech to text. It can transcribe continuous real-time speech into text. So if using your if you have application to do transcription, speech to text transcription, that you can use that service to do it in real time without any delays. Or sometimes when, for example, when you build an application for like a call center and you don't want to do it real time, you just say you can save those audio files with conversations and then push those audio files to the service so it can transcribe those files in batches. And I won't tell you what is more convenient and what is cheaper, because it depends on what kind of application you're building, what kind of audio files you have, what is the quality, how soon you need those transcriptions from speech to text. So it's totally up to you. You can try both options, and it is all available. So if you don't like one way, then you can always try another way. There's not a problem there. It can support intermediate results. So, sometimes when it translates speech to text, it can go kind of back, and then based on the context, it can actually fix the word. If it was misunderstood, then the service could go back automatically and fix the text for you without doing anything. It can detect end of speech. So, if you're doing continuous recognition, then at some point your speaker just stops stops talking, and then in order for the service to stop listening or stop receiving data, it can recognize it automatically. So you don't need to do anything about it. And if no one is talking, then you shouldn't be connected to the service, because it's on Azure and you're paying money for the cloud usage, right? It can support automatic text formatting, so it will format the text for you, and it supports profanity masking. Another good feature here is it can call on language understanding intelligence service, or LUIS, to derive user intent from transcribed speech. LUIS is widely used for bots design and development, virtual assistant skills. It is also part of the cognitive services suite, and it is really nice to combine both speech to text and LUIS, because LUIS doesn't understand speech. So you need to convert speech to text and then pass text to LUIS for LUIS to understand what the user wants, what kind of utterances are there, and what kind of entities are in the text. And I will show more about it during my demo. I'm using speech to text and LUIS, and you'll see how they can work together. Next, I have, but the speech services obviously have a feature called text to speech. So it can convert text to speech. It can provide neural text to speech voices, and they have so many different voices in supporting so many different languages, but they distinguish two different groups of voices. And again, it depends on your application and what is important for you and for your users, obviously. Um, if you don't need to have that voice that is really close to natural human voice, then they have huge libraries supporting different genders, supporting different languages, but maybe those voices, they are not so close to real human voices, but they're still really, really good. If you want to have voices that are super close to natural human voices, sometimes people can't really distinguish if it's a human voice or it is something artificial. Then they also have lots of voices. I started working with speech services maybe a year ago, and they had just 3 options available for neural voices. Now there are much more available voices. They support different languages. They support German and English, Italian, Chinese, and then they also support different genders. So it's totally up to you what kind of voice you want to use. Just go crazy there. And again, it converts text to natural sounding speech. That is what text to speech does. And another good thing there is that it supports plain text input or speech synthesis markup language, or SSML. And SSML, it is becoming that standard when you work with speech. I know that some third-party tools that are created for bots design and development and some speech services development, they are using SSML, so you can pass between the Microsoft Cognitive Speech Services and those third-party tools, or maybe your custom tools, or I don't know, tools from Google. You can pass SSML back and forth because it's pretty much a standard when you're working with voice. It's really cool that they're supporting it. And next we have speech translation. I translate streaming audio in near real time. It is so cool. I can't even express how cool that is because, several years ago, in order to do speech translation, what those, services they needed to do, they grabbed the speech and then they translated it to text, and then those texts in one language was translated to text in another language. And then the text in another language was converted back to speech. So it was a lengthy process. It just took so much time, and it just holds so much, so many resources. It was, long and painful. Now it is just awesome. They eliminated the text part, so it translates from speech to speech, and that's awesome. So it's faster, it's using less resources. It is just awesome again. Yeah, I said awesome so many times, but yeah, I am really impressed how well it works. So it can still provide results as text if you want to translate it to text. That is not a problem. Sometimes, when your user speaks and they want to see translated text, they probably can't listen, or I don't know. It depends on your application and your users. Or it can return synthesized speech right away, so they can hear how to pronounce it. Or if your user is using your application to travel, and they can just basically talk to your application, and then it will translate immediately their speech to another language. So really convenient. Okay, so if you checked all that awesome stuff and you're like, yeah, I like that all, but something is missing, something very important for me and for my business, don't worry. There is a custom option there, so you can create custom speech services. You can customize whatever models they already have. And first model that you can customize is acoustic model. And again, it depends on what kind of application you build in. But for example, if you know that your application is going to be used in a noisy area, maybe while someone is driving, or I don't know, just in a noisy place, then you can customize acoustic model. So it will kind of disregard all the noise that is not related to speech, and then filter just the speech, and recognize speech better even in a noisy room. Next, we have a custom language model. We all know one language or several languages, but even if we, for example, speak English, then there are so many different dialects or specific terms. How we developers are talking is a little different from how doctors are talking. They have their specific terms and how they use words and abbreviations. So in order for the speech services to understand better those specifics of how people from your business or from how your users are talking, what words they're using, how they talk, you can customize language model. Next one here is pronunciation model. That is really important. Again, going back to English. Here in the US, people speak English mostly, but even from state to state, they have different accents. And there are so many foreigners like me, I have an accent. And sometimes, people pronounce words in a different way. It doesn't change the meaning of the word, but sometimes that out-of-the-box speech service can't pick up some words because of the pronunciation, and you can customize that. It is really easy, and it is really inclusive. So if you know that your app is going to be used by people from different states or different countries with different pronunciations, definitely customize the pronunciation model in your speech services. And then the last one here is the voice font. And this is super cool. So for example, if you are building a bot on your website, like a speech bot, not the text bot, you can actually train your custom speech service to talk like your office manager, in your office manager voice. If your customers are used to call your office and then talk to that office manager, and they're used to her or his voice, then maybe it's a good idea to actually give the same voice to your bot. Or maybe you have a salesperson with really good voice that you want to use. You can customize that voice font using just several audio files, and then you basically train the model on those audio files. And then, the more you train it, the better it gets. So at some point, it will speak with the voice that is pretty close to that real person's voice. But here it's a little tricky, so be careful. You definitely need permission from the person. You can't just steal people's voices. That is not how it works. Don't do it. Don't be a criminal. And now let's move to Speech Devices SDK. I talked a lot about speech APIs, And you need to understand that their speech APIs and SDKs, they do pretty much same things. They have a little bit of differences here and there. You need to check the documentation if you have a specific case. In some cases, they're better handled by API, and other cases, they're better handled by the SDK. And then separately, they have that speech devices SDK. It can help you to rapidly test your new voice scenarios. And also using speech devices SDK, you will be able to create your custom wake word. For example, if you are using Alexa-enabled devices like Echo, then there's a specific word to wake up Alexa, right? But here you can customize your wake up word because that is your device, and you are customizing the speech using speech devices SDK. And Microsoft actually partnered with Rubo. So Rubo creates those devices that support speech devices SDK. So definitely check it out. I didn't have a chance to work with it, but if you worked with it or you have some feedback, definitely let me know. And now I will quickly provide an overview of similar offerings from Google and Amazon. I'm mostly focusing on Microsoft offerings, but it is really useful to understand that all major tech companies, they can provide similar solutions. And sometimes, it is good to either mix and match, or it depending on your clients, what they prefer, or what kind of technology you're working, what kind of applications you're building. So it's just good to know that there are other options available, and you can try them all, and then you decide what you like the best. So let's start with Google Cloud Speech Services. And here we have speech to text. Let me grab some water. Speech to text, it is really similar to what Microsoft offers. Here they actually recognize 120 languages and variants. It can automatically identify spoken language. So that part is really interesting, and I know Microsoft is working on improving that part in speech services, and I'm gonna show it in my demo. It can return text transcription in real time, and it can automatically transcribe nouns and context-specific formatting. So that is similar to what Microsoft is offering. Next one here is text-to-speech. You can select from more than 100 different voices. I don't know how many voices Microsoft has, but I know they have extensive libraries. So Google is also supporting all kinds of genders and different languages. They have so many different voices. It's really great. They also have neural voices that Microsoft call them neural voices. Google call them WaveNet voices. They mimic human voices, and they have more than 15. So that is really good. If that's important for you, then you can check it out. And it can support any application or device that can send a REST or gRPC request. So that is really useful. Next is translation. It supports more than 100 different languages. And we all know about Google Translate. Google is really famous for that service that they provide. So, the API that they offer for developers is used for that Google Translate functionality that users are using. It can, again, detect language, It can scale because it's a cloud can scale. And then they support AutoML translation, so it can customize model for you. So if you know a little more about machine learning and you want to use AutoML to create custom model for your translation, then that's a good way to do it. AutoML, really helpful. It can actually ease so much pain and free up so much time from a developer. So you don't need to go through thousands of different models to pick the best one for you. AutoML can do it for you. And Google is powered by AutoML and transfer learning. It is really good. So if you decide to check it out, definitely check the AutoML part. Next will be Amazon. So I worked a little bit with Google offerings here and there. Again, I'm mostly working with Microsoft technologies, so I can't really tell you my opinion, what is better and what is worse. It is totally up to you. It depends what you like and what kind of environment you're using. And for different applications, you might want to choose, different offerings from, Microsoft or Amazon or Google. It's totally up to you. With Amazon speech services, I haven't worked with those services. I don't really have any experience. I'm just gonna mention them. I know that they don't really have good documentation around speech services because it was really hard to find what kind of speech services they have. But if you work with Amazon offerings and you know that they're great, they have so many options, then that's great. I can't tell you really what's going on there based on their documentation. But what I found was Amazon Transcribe, and it is basically transcribing, it converts speech to text. You can customize your vocabulary there. It can generate timestamp. It can recognize multiple speakers and multiple channels. And by multiple channels, they mean if, for example, one user is using the application through the phone, and then another user is using through, for example, like Echo Dot, then they will recognize the channels, how your users accessing your application and through what device they are talking to the application. And they also can transcribe audio to text in real time, like Google and Microsoft offerings. And then Amazon also has Amazon Polly. They have natural sounding voices there. And so Polly, that is basically a text-to-speech translation. They have natural sounding voices. I didn't find any information about the number of voices they're supporting. If you know more about Amazon offerings, definitely let me know. I would like to learn more, but I just know that it's really hard to find anything there in their documentation. They have customizable speech output and then real-time streaming. Pretty good. If you are using Amazon solutions a lot, then that is good. It still supports, text-to-speech translation and speech-to-text translation. So you can use those tools. And now let's move to the demo. I have a lot of things to show, so hopefully we'll have we're online.
Hi, we're back. There were some technical issues, but we're giving back the word to Veronika.
Okay, I'm back. Awesome. So we stopped at this slide, the demo, and I was about to show you the demo. So that's the demo, the code, the most fun and important part of every presentation. And here you can see I have several things. So I'm going to show you as many as I can. But before we move to the actual code, let me tell you a little bit about online offerings, how you can access the Speech Studio if you want to use custom speech. You just go to speech.microsoft.com, and there you can go crazy, customize whatever you want. And I already told you before what things you can customize there. Again, they have a lot of documentation available. And yeah, so that's really important. If you're ready to build your speech services, then you need to go to your Azure portal if you have Azure subscription, or you can use trial version for I think 7 days. So basically, you're going to the Azure portal, you create a resource. So here you type in speech, and here you click and create. You add in all the important stuff, the name, the location. A location is very important. So you first need to think about what you are planning to use. If you're planning to use speech to text, text to speech, translation, or everything together, what kind of voices you are planning to use. And obviously, location should be as close to you and your customers as possible. But some languages or some voices, they are supported in one location and they're not supported in another. So be mindful about it. You can always, create a new resource and then delete that one if something is not working or something is not supported in that region. Then they have pricing tiers here, and then you can create a new resource group. So basically, when you create the resource, you will see something like that. So the key, don't try to copy my key. I'm going to regenerate it after, as always. And then the endpoint, it is pretty standard there. There is another option. You can actually run the Docker container for speech services. It's currently on preview, so I personally wouldn't recommend you to use it on production because Microsoft is still working on that. They're improving. And some other cognitive services, they're also available on Docker containers. So if you want to play with containers, definitely give it a try. And lots of documentation, some references, so you can learn a lot, and lots of great opportunities. The activity log, what's going on. You know how Azure works, so that's really useful. Not only for web versions, but also for the cognitive services and speech services. It is really useful to see everything here in one place and see how it all works. So for my demos, I actually created speech services, and I created Louis. So Louis is a separate service now. So before you could create just Louis using Louis.ai, the portal. Now you need to attach resource from Azure in order for everything to work correctly. So I also created that Lewis application. Here you can see the dashboard. So you need to create Lewis resource in the portal, on Azure portal, and then customize your Lewis application here using Lewis.ai. And when we go to build, I didn't do anything crazy here, so it's pretty simple application. I just added that translate intent, so it will help us to translate. So here we're figuring out what kind of text we need to translate, and then to what language, so target language. So Lewis will figure out what your user wants, and then based on that information, we will do it, perform the action that your user wants. So let's go back to the code, and we'll start with that one. So here, what we're doing, I am actually, so the configuration that is pretty straightforward here. The configuration is coming from the SDK. That's Microsoft.cognitive-services.speech. So you can set up the configuration using the class. And then you'll need to use the intent recognizer. And intent recognizer is related to Lewis. So basically what we're doing here, we are creating a Lewis model from the app that we created in the portal. And then here what I'm doing is I am creating a speech recognizer. So there are two options: recognize once asynchronously or continuous recognition. And I'm using continuous recognition in my other example in this demo. So here it is just once. So it can be one word or one phrase. It is not gonna wait and keep listening. It will listen once and then stop. And here I have everything very detailed. But in most of cases, you don't need it to be that detailed. So we are getting, so when we recognize the intent, we got the text. So we converted speech to text, and then we are passing the text to Lewis to understand what the user wants. And here we check in the intent. If the intent is translate, then we understand that user wants to translate that phrase. And we are also receiving the J object from Lewis that will explain what entities we have. So based on that information, we're getting target language and the text. And then we are trying to understand what target language that is. If we don't understand what's going on there, then by default it is English. So, and then we are synthesizing speech, and that's it. But there are other options there. So here, when we got result from, we recognize intent in Lewis, and we recognize speech, then we can return the text, but then we understand that intent wasn't actually recognized. So it means that something was there, that it understood it was some kind of speech, it was text, but intent wasn't matched. Like you saw I had welcome intent, translate intent, and hello intent. If it's something different, then we recognize the text, but we are not associating intent with it. So, or nothing is recognized, and we return in that information. And it is just a console application. It is really straightforward. The code is not perfect, so I don't recommend to use pieces of that code. And usually you don't need it to be that detailed in real applications. I just wanted to show you as many options as possible. So what we're gonna do, I'm gonna just run it really quick. Translate mother to German.
Mutter.
So I hope everyone heard. It actually translated it. And here I'm showing you the output from Louis. So that was the phrase that Louis, that we actually transferred from a speech to text first. And then we passed the text to Louis. And then Louis recognized the intent, recognized language, and then the text that we want to translate. And yeah, and then we passed it back to translation, and we translated it and synthesized the speech again. Okay, let me actually show you. No, we don't have lots of time, but let me show you another option here. So that is something relatively new. We are recognizing language. So for now, it is not perfect, but I know that Microsoft is working on improving it. Even like several months ago, we couldn't do it at all, but now it can detect language between two options. So here I put English and Russian, so it will recognize what language the user is using. So it's yeah, and it's also pretty straightforward. Here we're using similar configuration. We're using speech endpoint and the key. Those are same endpoint and the key that we got in the portal. And then we are providing some audio configurations. And basically, we're again listening just for one phrase or one word. We can do it continuously. I just don't want to do it here. And then we are returning result saying, okay, I recognize that speech and that language was that. So let's try this really quick. Translate mother to German. So it recognized mother. So it recognized the phrase. It was translate mother to German. And see, it even detected that German is language. So put uppercase there and recognized that that phrase was English. Okay. I think let's do we have a couple of minutes for one more thing?
A minute or two maximum.
Okay, then I'll show you one more thing and then I'll stop. I told you I have lots of demos, but yeah, I'm gonna put all that code on my GitHub. I have an older version there, but I updated it a lot. So definitely check my GitHub later. And here I'm doing the translation. So I'm translating from English to German and then synthesizing the speech in this part, and then I'm playing the audio file right away. So it is translation from speech to speech. And here I'm also recognizing it once. And let me run it really quick. I know we are out of time. Translate mother to German.
Übersetze Mutter ins Deutsche.
So you can see it translates it right away, and each word separately. And then when we finish the phrase, it actually translated the whole phrase for us and synthesized the speech. So we just needed to pass it to our audio output. And yeah, that's it. I think I'm ready for questions.
Thank you very much, Veronika. We have at least one question from the public. They're asking, can we download the translation model and use it offline, or does it need to be online?
So speech speech has two parts. It has APIs and SDKs. So APIs, you can use them through REST, and then SDKs, they are offline. So you can use some things offline. I don't remember from the top of my head what exactly can be used offline and what has to be online. Please check the documentation because they're updating it all the time. But another option, if you don't want to use Azure, you can use Docker. So speech supports Docker containers.
Okay. Well, Veronika, thank you very much for your time.
Thank you.
Although we had a technical hiccup,
That's okay.
but we managed to connect quite quickly back. So thank you. Have a nice day, the rest of the day, and it was nice having you over for the Global AI community on virtual tour.
Awesome. Thanks for inviting me. Good to virtually see everyone.
Okay, bye-bye. Thank you.
Bye.
Hey, my name's